Okay, so today we are going to work on operations with complex numbers. We're going to add, subtract, multiply, divide, simplify complex numbers. So the key is we're going to treat I as we would any variable except for the following. When we run into I squared, we're going to remember that that is equal to -1. And that's the most common. That's the most important thing. If we run into I to the third power, we're going to remember that that equals -I. Other than that, we're going to treat I just like we would an x. For example, 7i plus 9i would be 16i. So looking at number 8, we're just combining like terms. So if I have -5 plus 2, that's going to be -3. And then if I have 6 and -11, that's going to be -5i. All right? So be careful. When you have a negative sign in front of parentheses, you have to distribute that negative sign. So that's going to give me 2 plus 3i. But then I'm going to have -4 minus 2i. And then I combine like terms after that. So that's going to give me -2 and plus I. So that would be the answer to number 9. Okay. Multiplication. If I distribute this I, then that's going to give me -3i minus I squared. But remember, I squared is equal to -1. So for that reason, I'm going to have -3i minus -1, which would be the same thing as -3i plus 1. All right, and standard form for complex numbers is the form a plus bi. So we really should put the I term second. So I'm going to switch this around and write 1 minus 3i for my final answer. Okay, looking at problem number 2. We need to FOIL this or double distribute, whatever you want to call it. So for example, if I distribute the 2, then that's going to give me -12 and then -4i. And then if I distribute the 3i, that's going to give me -18i and -6i squared. Watch out for that I squared. Combining these like terms right here, I'm going to get -22i. So I have -12 minus 22i. But remember, this I squared is secretly a -1. And -1 times -6 is +6. So that's going to become a +6. And then -12 plus 6 is -6. So I end up with -6 minus 22i for the final answer. Okay, what else? The main thing with division is that we are not allowed to leave I in the denominator. So it's sort of like rationalizing the denominator. It's a matter of how do we get I out of the denominator. When the denominator is just a monomial, like 2i or 4i, the easiest thing to do is to simply multiply by I over I, right? Multiply by I over I. So that will give me 3I divided by 2I squared. But we know that I squared is equal to -1. So that's just going to give me, so this I squared is going to become a negative sign, which really I'm just going to put in the front. So, so now I have 3I over 2, -3I over 2. Okay, that's it. We'll do the same thing for the second example. We can just multiply by I over I. The only difference is we will have to distribute the I in the numerator. So in the numerator, I will now have I minus 7I squared. In the denominator, I have 4I squared. Okay, so the I squared in the numerator is a -1. Okay, so we know that this is really a -1, and this is also a -1. So in the numerator, I'm going to end up with I plus 7, because -7 times -1 is +7. And in the denominator, I have this -4. Okay? And we really should write the I term second, so I will just switch it around and put 7 plus I over -4. Okay? So this is the answer. All right, it's slightly more complicated when we have a binomial in the denominator. In that case, we need to multiply the numerator and denominator by the conjugate. So looking at the denominator, I see the 3 minus I. The conjugate is 3 plus I. Okay, so I need to multiply by 3 plus I over 3 plus I. In the numerator, I will distribute the 5. So I will end up with 15 plus 5I. In the denominator, I need to FOIL this, or double distribute, whatever you want to call it. So I'm going to show an extra step that I normally don't show. When you, well, you know what? I lied. Let me just say this to you. If we have A minus B times A plus B, the whole point of multiplying by the conjugate is that you always get A squared minus B squared for the result. It's always going to be A squared minus B squared. So in this case, I'm just going to go straight to A squared minus B squared. So my A is 3, and my B is I. Okay, so I'm going to go straight to A squared minus B squared, which is going to be 9 minus I squared. All right, I'm just going to go straight to that. So, but of course, I squared is -1. So that this is going to become 15 plus 5I over 9 plus 1. Okay, right? Because just minus -1 is like 9 plus 1. So that's why the answer is going to be 15 plus 5I over 10. Well, you know what? I'm not going to leave this as my final answer, because do you notice that all three of these numbers are divisible by the same thing? When all of the numbers are divisible by the same number, then you can do that division. So all of these are divisible by 5. So let's just divide all of these by 5. Okay, it has to be all of them. It's like all or nothing. But since these are all divisible by 5, I'm going to end up with 3 plus I over 2. And that's the final answer. Okay, this quiz on Friday is a simplification quiz. So it is important that you simplify as far as possible for full credit. Okay, this example has a binomial in the numerator and the denominator. I want you to focus on the binomial in the denominator because that's where the conjugate comes from. Okay, so I'm going to do my negative 1 plus 2i. All right, and I have to do that in the numerator and the denominator. In the denominator, it is very simple because it's going to automatically be a squared minus b squared in the denominator. And this is my a, and this is my b. So a squared minus b squared is positive 1 minus 4i squared. Okay, that's my a squared minus b squared. In the numerator, I am going to have to distribute. So distributing the 3 gives me negative 3 plus 6i. And then I distribute the 11i. So 11i times negative 1 is negative 11i. And 11i times 2i is 22i squared. Okay. Of course, we are remembering that I squared is negative 1. So on my next step, I'm going to have, if when I combine these like terms right here, that's going to give me negative 5i. So I have negative 5i. This negative 1 is going to turn the positive 22 into a negative 22. So I really have negative 22 and a negative 3. So that's negative 25. Okay, so that doesn't need to be that long. And in the denominator, this negative 1 times a negative 4 is really a positive 4. So this is 1 plus 4, so this is a 5. Okay, for full credit, do not leave your answer like this. Notice that all 3 numbers are divisible by 5. So if we divide everything by 5, I won't actually even need this fraction. If I divide everything by 5, I'm going to get negative 5 minus I over 1. But of course, we don't really need the over 1 part. So for full credit, leave your answer like this. Soak it in, people. Soak it in. All right. So looking at this problem, we have a monomial in the denominator on the first one. So to solve that, we will multiply by I over I. Going to multiply by I over I, man. We'll have to distribute in the numerator. So that's going to give me 7i plus 5i squared divided by 2i squared. But we know that I squared is secretly negative 1. Okay, that means that this is really a negative 5, which I will put in the front. So I have negative 5 plus 7i. And in the denominator, we have negative 2, and that's it. Okay, here we have the binomial. So I'm going to do the conjugate. So I'm going to do the conjugate of the denominator is 1 plus 3i. So I'm going to multiply by 1 plus 3i over 1 plus 3i. In the denominator, it's just going to give me a squared minus b squared. So a squared minus b squared. So that's positive 1 minus 9i squared. A squared minus b squared. In the numerator, I'm going to actually do the distributive property. So I'm going to distribute the 2. And that gives me 2 plus 6i. And then I'm going to distribute the 6i. Blam. Blam. All right, 6i times 1 is 6i. And 6i times 3i is 18i squared. Okay, we know that I squared is negative 1. For that reason, on my next step, let's see, combining 6i and 6i gives me 12i. So I have plus 12i. The negative 1 times the 18, this is now a negative 18. Negative 18 plus 2 is negative 16. In the denominator, this is really plus 9, so I have a 10. For full credit, do not leave your answer like this. I notice that these are all divisible by 2. So for full credit, I'm going to put negative 8 plus 6i over 5. Okay. All right, looking at this one, binomial in the denominator. So let's do that conjugate. So we're going to do 2 minus 7i over 2 minus 7i. Okay, in the denominator, it's just going to be a squared minus b squared. So that's going to be 4 minus 49i squared. Okay, it's always a squared minus b squared when you do the conjugate. In the numerator, I'm distributing, so I will have 8i minus 28i squared. I squared is negative 1. So on my next step, I'm going to have the negative 1 turns the negative 28 into a positive 28. So I have positive 28 plus 8i. This is now a positive 49. So I have positive 49, 4 plus 49. So that's going to be 53. So that's it for that problem. And then similarly, I'm going to do the conjugate again. So I'm doing negative 4 minus 3i. Negative 4 minus 3i. Okay, let's see what happens. You know what? I think I'm gonna squeeze it in underneath here. So in the denominator, when I do the conjugate, it is always a squared minus b squared. So this is going to be 16, right? That's a squared minus 9i squared, all right? It's a squared minus b squared. In the numerator, I need to distribute. So distributing the 4 gives me negative 16, and then negative 12i. And then next I distribute the negative 3i. Negative 3i times negative 4 is positive 12i. And then negative 3i times negative 3i is positive 9i squared. All right, but we never forget that I squared is negative 1. So therefore, on the next step, well, the negative 12i and the positive 12i cancel each other out. So those are gone. The negative 1 makes this a negative 9. So I have negative 9 and negative 16. So that's going to be negative 25. And this negative 1 makes this a positive 9. So this is really 16 plus 9, which is 25. Okay, so that means that this is really just negative 1. Okay, and you know what? Now that I see that the answer is negative 1, I feel foolish. I really did that the long way. Yeah, so I'm going to just erase all of this. So, I mean, that was good practice, but here's what I would have done if I were smart. Because you can see how close these are, right? I have 4 minus 3i, and then down here I have negative 4 plus 3i, like they're almost the same. So the smart thing to do, and I mean there's nothing wrong with the way I did it. So if you don't notice this trick that I'm about to show you, if you do it the long way, you still get the right answers. Totally fine. But what if we just factored out a negative 1, right? Imagine that in the denominator, we just factored out negative 1 like a GCF. Can you see that that's going to leave behind positive 4 minus 3i if I take out the negative 1? Okay, and then in the numerator, I have 4 minus 3i. So you can see that the 4 minus 3i and the 4 minus 3i, they just cancel each other out. And that's why the answer is negative 1. So that would be the smart way to do it.